Thank you, everyone, for joining us in this session to dive in a little deeper into the what, the why, and the how of quantum computing, and of course, the post-quantum cryptography. Enterprises are definitely gearing up towards architecting for a cyber-resilient, continuous business model. So when it comes to architecting for the unknowns, it can definitely get overwhelming real fast. If you could explain like I'm 5, ELI 5, what is quantum computing?
So when I think of quantum computing, quantum computers really leverage the principles of quantum mechanics to process information. So that's really what separates them from classical computers. And quantum machines use qubits, which can exist in multiple states, versus classical computers, which are just zeros and ones. So that's kind of the foundation of how these are functioning differently. And because they can maintain multiple states, this creates exponential scale, and that's really what gives them their computational power. And sure, I'm abbreviating this, trying not to get into any crazy terminology, but it's worth mentioning that quantum computers are not going to be used for generalized compute. Like classical computers will still be around to provide computation across a more generalized sense, as opposed to quantum machines, which again are really good at factoring very large numbers, massive topic spaces, and simulations of molecules or chemistry or materials.
That's fantastic. Thanks for the thumbnail on the definition or what it actually means from a quantum computing point of view. But how do you see that having an effect on the way organizations are going to start protecting their data, especially from a cyber recoverability and readiness and resilience point of view?
Yeah, so I would probably answer that in two phases, right? We're seeing that there's massive transformational advantages in the quantum space. And again, there's certain key areas: drug discovery, climate and energy solutions, logistics, and material sciences. So historically, these businesses used to spend decades doing research. They would spend billions of dollars. And, quantum machines are really accelerating their ability to innovate from that particular standpoint. So things that used to take a decade could take, weeks or even months on quantum machines. And I would say that, they also you could probably use them as a calculator. So your calculator on your desktop, crunching, massive numbers and polynomial factorization is what they do best. And because that's what they really do well, I would say that for protecting data today, quantum threats could absolutely affect data encryption, networks, and key stores. And, if I had to sum up like what those are really technologies that use asymmetric cryptography. So I kind of put them all in that box. And, that's where I usually start to talk about Grover's or Shor's algorithms and potentially breaking RSA. The other thing that's certainly worth mentioning when we're talking about data is, how sensitive is your data and how long does your sensitive data need to stand around? Mm-hmm. And if that isn't a really long time, then today's methods of encryption are certainly good enough. Mm-hmm. AES 256, as an example, is pretty resistant to even quantum threats today, where it would still take an enormous amount of time. It's not thousands of years like classical compute, but it's still certainly a long time. But if you're one of those organizations that has trade secrets or the military or government documents, or, if you got mad Bitcoins, you probably want to look into some of these technologies to protect them. And for all the folks that really do fall into those categories, that's why we innovated and released post-quantum cryptography, or PQC, within our product.
I think you bring up a very good point there, Michael, because when you talk about sensitive data and how large volumes of data are actually being housed for maybe long-term compliance retention requirements, like your healthcare data, financial information for audit purposes, in a lot of these cases, I think the longevity of the data itself is exposing the risk or increasing the risk factor by manyfold, because these are now susceptible to harvest now and decrypt later kind of attacks, which makes perfect sense, because now you're trying to wait for the post-quantum cryptographic capabilities to ramp up and mature to a point that you can actually leverage that sensitive data, crack it open, and use it against the organization in the future. which makes perfect sense if you ask me. But in the larger scheme of things, how do you see Commvault's integration with post-quantum cryptography being complementary in nature? What kind of threats do you think it's solving for?
Sure, PQC could be used in a lot of these scenarios, but I would certainly recommend that people still continue to deploy other tactics to protect an environment, right? PQC should be considered like just another layer in the many layers of security that an environment uses adjacent to all the other controls. Again, preventing things like breaches and exfiltration risk. Um, Getting back to something similar to what I said before, highly sensitive data is really where you want to use post-quantum cryptography. And again, that data should also have, a combination of being air-gapped and safeguarded with various controls. And if I had to like really break down what would have to happen for that data to be reconstituted, someone would have to break into an environment. They would have to crack the PQC encrypted tunnel. They would have to steal that data in addition to all the original data from where those blocks are being referenced. They would have to reconstitute and organize them together to actually get to the data. So you can see this is one of these things that is just not feasible. And this is how we're really delivering next level cyber resiliency to our customers.
Fantastic. I really love the way the two parts and pieces actually come together to make sure it's not just the cyber resilience of the data alone, but also the entire schema around it that rallies to ensure that the organization is cyber resilient.